and the two not in contact. Let it be like this. A. No, I'll give only density. This is sphere with cavity. I want the field strength inside the cavity. And these are the types of numericals also you can expect here. Look at the cavity, I shifted somewhere there. So what is the best method? So first you take some arbitrary point. Let me make it a little bit big. So there's a cavity, no? So I'll resume all this. No, let me take a little bit, I'll show bigger so that diagrams I can draw easily. Now, only if there is a solid sphere, how the field would have been like this, no, from the point P, and due to cavity, it'll be like this, and this is what O2, no. The same idea. This is the same idea, no. Directly, you need not to draw so many diagrams straight away. There's a point P. So what about the thing that one? So we should draw like this, no, a vector. But they are not given mass, no. They are given density. So tell me what shall I do? We should know how to find out the field inside the solid sphere in terms of density. Okay, let's do one thing. Let's arrange the formula because we don't have formula, no. Let's arrange that formula. What the formula it says? Gm r by r cube, no. What is density? Mass by 4 by 3 pi r cube. Will agree? There's a formula. So this m will replace there. This m is a quantity we are going to replace so that we'll get answer in terms of density. So when I do that replacement, g by r cube, I'll keep it here. So what is m now? Rho 4 by 3 pi r cube. R cube get cancels. So this everything will be 4 pi rho g. Look at this formula. It's still more easier. If they give density only, it's easier than mass. R cube only will get eliminated. So 4 by 3 pi rho gr. So now, do we know this E1 bar? So what is this? This is E1 bar, no? And this is E2 bar. And this is the resultant E bar. Let's calculate E1 bar. As if there is no cavity, what is E1 bar? Looking at this diagram, so what is E bar? This is some. Okay, that E will get confused, no? I'll write E1 bar only. This is a generalized formula. Okay, let's come for this one. What is E1 bar? E1 bar already I brought it. So this is for sphere it's a generalized formula. So what is the net E bar? Net E bar will be E1 bar plus E2 bar. Already E1 bar we know 4 by 3 pi rho G. What is small r? Small r is nothing but that P over 1 bar plus this will be 4 pi rho G. This will be O2 P bar. PO1 bar plus O2 bar is needed. Now what shall I do? From where I should bring this one? I think there's a vector, no? That vector will come for it. We know this distance is how much? The total distance is A, and this is what the B. This distance is what is needed. If you know this distance, substitute, you'll get the required answer. This distance is what B, we know it. Okay, this one. So if they give this distances O1, O2, that you substitute, we'll get it. So the final answer will become, and again it will be uniform everywhere inside the cavity. This is what E. So how that field, you have to show it somewhere like this, huh? Along O1, O2. If the cavity is here, it will be along O2, O1. If the cavity is here, if cavity comes here, then